Now we are going to come to the topic software is a game changer for 24/7 operations, and you will get practical tips for everyday use. And this will be done by Roland Wagner, Head of Product Marketing at CODESYS Group. And Mr. Wagner, I'm looking forward to a really interesting presentation. Yes, thank you for allowing me to be here. And first of all, I would like to give you an overview over the next 20 to 25 minutes. First of all, I would like to tell you a bit about failure safety. Then I would like to discuss several levers which allow us to guarantee failure safety or at least minimizing risks for failure. And then I will conclude. Okay, coming to failure safety. Where can failures happen? Every day, everywhere in life. Winter is approaching, your heating might break down, and then it would be nice to have a workaround that allows you to get a bit of warmth. Or you're waiting for an urgent supply, urgent delivery, and the transport medium is breaking down. Okay, that's bad, but these are things that can happen. Okay, and for larger companies, there are also some failures which are really a bit bizarre. This is a nice picture that I saw. This aircraft could land safely, but obviously it will no longer be operable until it was repaired or will be repaired. So there can be events happening that cannot be predicted. Or a very classical example. We all know football, and some love it, some don't. But I will still refer to some football examples. And my favorite player, Thomas Müller, might fail because of this foul, and then he needs to be replaced. And this is something that cannot be prevented. And there's a law, a rule, which is called Murphy's Law, and he says anything that can go wrong will go wrong. And we know that Murphy was an engineer from aviation, and he came to this conclusion because he knew that if one can operate something in a wrong way, this will be done. And this is why one would have to cover all eventualities to protect against failure. But one thing is sure, trying to completely avoid failures is impossible. In reality, there will always be failures. But the question is, how can we minimize the risks of such a failure? And how can we prepare in reducing damages of failures? And thus, I thought the conclusion is, let's learn from the professionals. And how do they minimize their risks? Well, first of all, they have an overview over their players and their situation. For how long have they been used? And might there be some initial signs of wear or failure? And again, think about the airline or the football players. This is something that you can detect. And once you detect it, then the question is, how can you make sure that you've got adequate replacements? I just put two examples. Do you have an idea how big the FC Bayern Munich squad is this season? I tell you, 26 players. And you know that there are only 11 that are allowed in the field, plus 5 that can be exchanged, so 16. So there's quite an overlap. And the first lever, that is this overview, which player is in which training quality condition. And if you're then the manager, then you can either leave this player as a substitute outside or ask him to join the field. Or Lufthansa, they've got more than 700 aircraft in operation. They're not all in the air. Some are grounded, waiting for being used in emergency cases. So you need adequate replacement. And if that is not sufficient, then there's a third, quite elaborate lever, and that's redundancy. And to use redundancies has to do with risk assessment, with costs, but mainly with cost calculation. How much will a failure cost me per hour, per day? Maybe also what will be the cost with regard to other risks. And coming back to aircraft, this is why they do not just have one control system, the white control system, but 2 to 3 control systems on board so that in case of an emergency, the aircraft is still operable. In nuclear power plants, this is even more elaborate. We've got 4 redundant control systems which make sure that a power plant remains controllable and clearly manageable. These are 3 levers that I would like to present to you. And in automation technology, I would like to present them in more detail. Coming to preparation. And preparation is everything. We know this from school. And this means in automation, we always have to know what's going on. But how are we doing this? First of all, we need to gather all kind of information and, if possible, save these centrally. One is using the server. In football, it's the manager who observes everything. But in automation technology, just as for IT, it's servers who should play the role. And these servers can then monitor via digital twins what the players are doing. Well, what are the players? We've got automation devices and control systems. And the CODESYS automation server could be such a player. I've got a screenshot, but I will take this away. I would like to show you live the situation in my browser. So I logged into a server protocol which is linked to a control network. And we said we wanted to have an overview, and the overview can be provided in different ways. For example, here, topology, here you've got the graphical view. That looks quite nice. Even more informing is the list view. And here I can see, oh, there are some devices included in the server, so they've got a specific connection to the server, and how that looks like will be shown in a moment. And then you see some are green, 3 are red, and 1 is in a biworking mode. It looks as if a colleague were working on it. If I click onto a device that is not available, okay, this is not there, but still I see some information as to what should be there. Let's go back and let's open one which is available. So I get the device name that can be changed. I can change it. Information about the project and the application that is running on it. Then information about the connection. And as I said, we will come to that in a moment. Then the name of the device, the manufacturer, and very important information, firmware and lifetime version. So are there any newer firmware versions which should be used, or maybe they have already remedied a fault that could lead to a failure? So this could be already an indicator saying, oh, let's exchange the device at possible, or at least let's update this device. Then there are a number of other informations, and I can choose them selecting the buttons. And one is the access rights to the device. We come to that later. But I could also have a look at the visualization, and we will do that. The web visualization, what is happening, I will show you, explain later. From my network, I now connected to an existing network on a secured connection. And here I can see what is happening on the visualization. And I could impact, switch something, or change parameters if that were necessary. Let's go back to the server. A further information are the parameters that are stored on the device. These are variables which I could change, diagnosis functions or other figures, and these parameters help me to understand whether anything in the device already points towards a failure. Another information that is important is which application is running on it. We've already seen it here, but per click I can also select this, and then I can see the situation about the application, how it's been used. But again, we will come to this a little later. And then if everything fails, I could directly connect to the application on the server, and we will do that also a little later. And then I could do debugging. And then, last but not least, I've also got the possibility to analyze data on the control, because here is the corresponding analysis tool. So their data are graphically processed and prepared in such a way that specific indicators show me, oh, this device might break, or something might break in the device, and the data would tell me, we would have to exchange this device during the next maintenance window. So let's go back to the presentation because we've seen all this. And this is for your documentation. So how can all this be monitored? Well, you've seen it. I use a browser, and it's irrelevant on which device the browser is running. Ideally, on a PC. Why do I say ideally? Well, because then I've got the possibility to do debugging on the device, because then I take a CODESYS development system that will be started and I can download the application. And on a tablet or a smartphone, this is not possible. However, in order to get the information and to monitor what is happening, just mobile device works. And it doesn't matter where I am. Ideally, I'm locally separated from the control network and also from the control system and the IP area. So I would not be able to access the network through other devices, not without additional software. And so within the application, I can prepare further information, which could also be an early indicator for a device needing exchange. For example, operating time counter, which I could compare with the maximum operating time that the manufacturer specified, or a number of switching cycles where I might see, oh, I get into saturation. I don't want to exaggerate it, or I'm very close to the maximum. And then I prepare for an exchange so that I'm not hit by the situation unexpectedly. And then one could also pass on data to a service which is not part of the application. For example, behaving the normal behavior with actual behavior, especially when we're talking about a drive or a driving movement, then one could easily understand, am I still in the area of tolerance or am I going beyond this? And then I could see, oh, wow, it looks as if I needed to exchange something, mechanics or maybe even the control unit. So this means I've got several opportunities. But the question is, where's the server running? Okay, that's obvious, it's on the cloud. And is that secure? And the answer is a clear yes. Why is that so? I would like to show you a graph to explain this. The communication paths are separated so neatly that nothing can happen. Let's start on the right-hand side. That's the control technology, the control unit. The devices are not directly linked to the internet, but they use an edge gateway, and the data are abstracted from the network and then transmitted in a secure way to the cloud. So here I've got an end-to-end encryption with TX10.9 certificates, the same that we use for online banking, and thus I can be certain that nobody will penetrate this and read the data. On the other side, from the end device, for example, a PC, independently on where it is, we also have end-to-end encryption in order to access this account and have a look at the data. And the data themselves are secured. We even have been given a certificate, and I will just show it to you on our website because we just renewed it a couple of weeks ago. We do it regularly, so you see this is secure. And it fulfilled all security requirements. Okay. Now it closed the wrong window. No, that's it. So what are other security features? Encapsulation of the network from the cloud, then the end-to-end encryption. But within the cloud account, there are different roles, and then you have different passwords and access roles, and this is a clear separation. And this is not just on the basis of roles, but also on the basis of objects. So going back here, for example, for this one device, I can say not everybody should access this, but only those who, the developer and those whose operator, and the others should not at all access this. So in a very meticulous way, I can encrypt this. And then we come to the application in a moment. There I also have access rights and tickets. So there are a multitude of possibilities, and for the access itself, a two-factor authentication is required so that nobody can easily guess the password. And we avoid failures by using maintenance windows in a timely manner, and also by replacing preventively if one is reaching, for example, upper limits or reaching them soon, or once we see that something is not really running easily and you can ask somebody else to warm up for a possible placement. Now we come to the second level of possibilities, replacement. What do you need to replace? It's hardware, of course, because hardware fails. And this is why it's a good guideline or recommendation to have replacement devices on store, or at least to know supply chains in such a way that you can order just in time. Once a preventive recognition then indicates a new device that you can order it in time. And this can be changed, and the change could be done by an electrician. It doesn't have to be the developer. However, once I exchange hardware, where does it get the right software? And this is very different from football. If Thomas Müller joins a match, then obviously he had been watched the match. The manager will brief him, telling him where exactly he should position himself and how to play his role. But actually, he knows about this. But for a control, this is different. It's naked, and the software that is put upon will tell it how it is working. And this is why other good tips are: do regular backups of your application and of parameters. And here in the CODESYS development system, there's a specific button for this, and this allows to do backups out of this tool. So you read out the information from the control and put it on a hard drive. So this is one possibility of doing backups. And these backups should be structured well and should be centrally stored. And it would be practical if the local electrician would not have to work with tools like installation and licenses. And it should be clear, and very clear actually, that the correct software is played onto the correct device. And what is one using for this? The server. And again, I've changed from presentation to live operation. So here you see the application which are put onto the cloud platform. Again, with all the safety and security mechanisms that exist in the tool, so I can secure via passwords or dongle or XO59 certificates these applications. And if I look at the application, then there are many different versions that have been stored. Okay. Now, the worst case happens. A device fails unexpectedly. What can I do? Through the server, here, for example, I can click Replace PLC, another service technician who will be given a ticket, and I can pass the information to him to say, replace this device. And press the confirm button. And then I press create ticket, so the service technician will get a long service number by email to his account, and he can use any kind of web browser using this service number and get into an independent window, have a look at the server, and then play use the software. And now, as this might take a little long to show this live, I will not really show this to you live, but you would enter the data. So this is the window that the technician gets, and then he would enter the serial number of the device, and through the ticket, the right number, and software is connected. And if there's a QR code, he can also use this through the camera. And thus, there's a connection between the application, and then the application is downloaded via the gateway server to the control, and then the software is started. What he needs is very easy, just an internet access, a browser, and the email with the ticket ID. So it's really not complicated. It's not rocket science. Anybody can do it. Or he enters a new function. Via the servers, you can roll out the application, and let's have a look at this live. So we enter the application again. And for example, you can see where the application is running. Oh, nowhere. That's interesting. So let's take a different version of this application. So here we've got even different versions of application. You can see who created it and when. And this version has already been integrated into the control network. And this version could then be also downloaded to another device. So you press the button and download depends on the internet connectivity, but after a few minutes, this should be stored on a new device. Okay, the manager is impacting from outside, screaming and directing the players. Can you also do this? Yes, through web visualization, because here through the web visualization, I can have complete impact on my application. That is what I prepared with all the security features, and I can also open service windows, or I use the login with CODESYS, the development system. If I press that button, then the local CODESYS is started. Okay, that's the license, but that's not disturbing. And now the connection of my local development system to the control is built up. Now I have to log in using my credentials. And now I can see which variations of the application are existing. This is only one. That makes it easier, but otherwise I could choose different variations. I just need a local storage place on my hard drive, press OK, and then download this to my system. And from the development system, I can then log into the control unit wherever it might be, anywhere in the world. Okay, coming to the last point, redundancy. Okay, in football, this is forbidden and impossible. You can't have the same player playing twice and even playing in parallel. In aviation, one might be able to do this, but it's not economical and not really possible. But in automation, it's no problem whatsoever. So the same control can be installed in my system in CODESYS. You can do it through the redundancy function, so have it twice. And these two devices are appearing as one single device for the program system. And then you have an additional software on the programming tool and on the devices. And again, we will quickly look live how this looks like. So a simple sample project. And here I have redundancy configurations. And I can then have the configuration. Here I've got the two devices. And both devices have to be found physically and selected. So I chose two devices that are identical. So two soft SPS system, soft PLC system, and this could be done for both sides, but I just save time. So what is important is in the redundancy settings, I can do further things, for example, the direct connection between the two systems. And this is very important because they control each other, and one might take on the task of the other one, which means there's both PLCs are executing, and this in a synchronous form. And what I can also do is I can activate visualization, and the visualization that is running in a browser is collecting whatever it is, the correct information to collect, so that I've always got up-to-date data. If one of the two systems fails, independent on whether it's the active PLC or the standby one, then I've got enough time to exchange them. And usually it's the active PLC that fails, then the one in standby will be activated and takes on, and then I can exchange the former active PLC so I can have a smooth, interruption-free system. And in order to make this synchronous, I've got a very clearly defined boot up, synchronizing and executing system so that this will also clearly and properly synchronize. So the time is almost over. Failure safety. that is very difficult to achieve. But to minimize the frequency, this is something that we can do, and we saw different levels, and we can definitely minimize the risk. And this is why you should be aware and know what is happening, monitor the current situation, prepare proactively for the replacement of your players or controls or PLCs, and use for this a server-based administration, which also allows you to monitor and remotely adjust. So intelligent software allows this, like CODESYS, which provides an overview, which supports many management and preparation tasks, and supports fast and smooth replacement, and enables genuine redundancy. And thus, the risk of such a failure is clearly minimized. And thus, a software like CODESYS is a genuine game changer and makes sure that you will become the master of the league. Okay, that's the end of the presentation, and I'm looking forward to the questions you might have. So, thank you very much, Mr. Wagner, also for this nice analogy in football. And if the companies working with CODESYS are just as successful as Bavaria, then that would be nice. But I've got one question. When I need to replace a failed device, maybe the software has not been licensed for this yet. How can the server help? Well, there's also a possibility in the server, and maybe I will quickly switch it on and show it to you, because here you can already place licenses. For example, here I can import licenses through an email which used for soft SPS systems. And if I say this PLC, soft PLC, and this PLC doesn't have one, and I can just choose the PLC that I need, and could then really connect it to the license that is required for this PLC. So we've prepared for this. Okay, then another question. In your presentation, you were talking about PLC redundancy and how this works using the CODESYS server. And what are the areas of use? In which areas do companies make use of it? Well, especially in areas where a risk of failure entails high costs. We've got customers which use it in crude oil industry or in energy industry in general, where a failure has consequences, but also in other areas. Whenever there are high costs involved, automotive industry, for example, that would make sense. Okay, but for a small machine where a failure really doesn't cost a lot, there you have to calculate business economics-wise whether it makes sense. And it might make more sense to accept an hour of dropout, and this is what the companies usually know best. Okay, and what I'd also be interested to know, could you tell us what are the prerequisites? What is needed to use the server? Is there anything that you could tell us in general? For the automation server, you just need an internet access, and of course IT has to approve this. In some cases, this is still a bit of a problem. That is, data which are required for operations for a machine have to be stored externally. But as I said, we have introduced so many security options, so security-wise, it's not really an issue. And apart from that, just test it. The CODESYS automation server can be used independently without cost with 1 or 2 PLCs. So just give it a try, as many students do it right now, because it's a nice possibility. So when you're at home having a project and you're at university and you just want to see whether the project is still running as intended. Okay, thank you very much. So free of charge testing, and if you then think it's a good idea, then one could continue. Okay, wonderful. Thank you very much, Mr. Wagner. Thank you for this presentation.